Next up, we have Chris Perkins from Flagship. Chris is the director of Lab IT, and Chris helps Flagship companies manage the IT assets that they acquire, store and transfer research data from laboratory instruments. Previously, Chris led a laboratory IT support at Takeda, supporting GXP manufacturing, scientific data management, high throughput inventory, chromatography, protein purification systems, on and on and on. Chris also formerly worked at Biogen as well, where he designed and developed an ELN and laboratory information management systems for R&D. Chris will be talking to us today about raw data movement modalities. So welcome, Chris. Thank you.
Thanks very much. Appreciate the opportunity to speak to you this afternoon. Hoping that this is useful in some way to you. This is a version of a talk that I give internally to scientists at startups. And usually these are companies of 4 or 5 people who have just come from academia and they have no idea how the real world actually works. So I also hope that some of this is useful to people who have been in the industry in a while to think about how we're trying to start from a clean slate. And we have the opportunity with these startups to not burden them with a lot of the infrastructure that we rely on. However, it does sort of handcuff some of the choices that we get to make. So I've never actually timed this because I get interrupted about 1 slide in every time. So please feel free to interrupt. So this is a common scenario to many of the people in the room, a frantic phone call that you've just received that the instrument is on the loading dock and IT needs to come down here right now and talk to the vendor and help us get this installed. And normally some member of my team or I will put on a lab coat and go down and help them. But while I'm talking to the researchers, I'll start asking the questions about, have you thought about how this data will flow? And invariably, these very educated people say no. So we talk about raw data capture and storage and who's going to access it. And I would say that a trend that I'm seeing, especially in the startup world, is that the computational dry lab is almost more of a priority than what happens in the wet lab. And so those consumers of those data really need to have fast access to it. And of course, management always wants to see updates and slides in progress. So, we spent a lot of time, and a lot of the great talks today have talked about data ingestion and how it gets in, but there's sort of like a missing piece to a lot of these talks about, like, how does the data transport mechanism, how do the raw data actually escape from the lab? And I like to think about our labs at Flagship as being a zoo that is not very good at locking the doors, and the data just sort of escape as the animals might escape from the zoo. And so we asked some researchers to think about the data type and the data size. Right? If you're doing next-gen sequencing, that's a very different thing than for flow cytometry. We're talking about the available infrastructure, and for startups, we don't have infrastructure. Right? These are not well-funded companies, and they'd have maybe enough money to buy 1 or 2 instruments and run their experiments. I remember when I first arrived at Flagship, and a customer was describing a problem to me. I said, "I'll just have the DBA team go work on it," and I turned around. And there's no DBA team. So these companies really need to think about how this is going to work. Vendor limitations, I don't think it'll be a surprise to anyone in this room that instrument vendors limit the ability for us to get data off, sometimes by design, sometimes because that they're hardware vendors who don't know how to write software. Sometimes you only get to make bad choices. Sometimes instruments come and they arrive in our labs and they just have a USB port. There's no network port available for us to get the data off. So we don't have good choices to make in that system. So the idea for this talk is I give a decision tree to help make a good choice with a limited set of options. Guiding principles that I try to drive at Flagship is that raw data and the associated metadata end up stored in a cloud-hosted data lake. And that's where we're trying to get to. And we don't want to choose to burden our companies with on-premise infrastructure. We'll talk about that in a little bit. That said, the tools in a cloud-hosted data lake for operating for a wet lab scientists are really not that user-friendly, and I'll talk a little bit more about that. But really, as I go through the different options, we're going to look at the user experience, how much money does it cost, compliance with FAIR principles, security, and of course the ongoing overhead for the team. There's a lot of solutions that sound great, but then you realize you need to hire a team to maintain it. So I encourage our lab users and lab managers to plan for data as they plan for power and gas. I cannot tell you how many times in the past 2 years I've installed an instrument in a lab and they placed it somewhere where there are no data ports. And I think you guys are just not thinking about this the way that we need you to think about it. We've started a new process to get people to start to think about how do we provision data in the labs, but it's an uphill battle for us. We're also working closely with vendors to make sure that we get the antivirus and patching right. It's still something that we struggle with, and we shouldn't have to in 2023. And my goal really is to automate the data acquisition as much as possible. But there are limitations even in the software from the instruments. You might not be able to set a default save location, and you have to sort of divine where the files get written to. If you're a scientist at a startup and you just come from academia, the options are overwhelming about how you can get your data out of the lab. Cloud-hosted systems is a probably overused term in our industry, but it's still sort of mystery for a lot of researchers. And especially if you come from academia, you're not used to calling IT to help you. You're used to solving these problems on your own. So you're presented with this number of options, it can be overwhelming. So probably the most common that I saw when I joined 2 years ago was SneakerNet. And when I joined Flagship, and I hope there's no one here, less than 50% of our instruments were actually even networked. And that was sort of where we started. A lot of instruments today can't be networked. If it doesn't come with a network jack or it's just not built into the functionality, a USB drive might be the only way that you can get data off. I've also had users physically stand in between me and an instrument and try to prevent me from putting it on the network because they're afraid that I'm going to break it. Someone in grad school must have hurt them. I don't know what kind of trauma they've been through, but this is something that we see. And especially in a startup, when they have a limited amount of runway, any risk to the data is unacceptable to them. So they might not be willing to even put the data, the instrument on the network. I have vendors today who tell me that we cannot run antivirus software on our computers. And this to me is maddening. Maybe Neil, if he was still here, could talk about COBOL. That probably wouldn't survive it, but everything else today really should be able to survive on a modern network. SneakerNet is great user experience. It's easy. You just copy the data and then you leave. And of course, everyone in this room probably knows there's no backups, there's no traceability. You won't be able to find the data later. I did not change the names to protect the guilty instrument vendors on here. I'll let you decide for yourself. But Hamilton's, and I don't want to pick on them, they're especially difficult to work with in a lab environment, and we've had to twist ourselves in knots in order to support them. So probably the solution that most of you are familiar with is an on-premise file server. This is a really good solution to a lot of these problems. It requires a physical server on site, and if you were in a shared environment, where are you going to rack it if you don't have a rack? And now you have a server that needs care and feeding. Someone needs to update it and back it up. It's great because you have total control over it, and it's terrible because you're on the hook when it breaks, right? And there's no one to save you. This is the only option in some environments where the instruments require a low latency data connection, and we see that cryo-EM is probably a good example of this. It's just not going to be able to write to someplace far away. Like I said, DR and high availability are expensive. And now the data are sitting on-prem, and the dry lab scientists are sitting there rubbing their hands together, waiting for the data to arrive in the cloud so they can bring their analysis workflow. So you still need a way to get the data into the cloud. Imaging and flow cytometry, common offenders in this space. Enter cloud file servers. This presents easy, cheap, and virtually unlimited storage to the users. And they may even have OneDrive or Ignite installed on their lab computer, and they just start to save data there. And that's great. It requires zero care and feeding. You do need a fast internet connection to make this work. Not all instruments support it. So we see a lot, especially in the mass spec space, where the vendors tell us you can't acquire data directly to the cloud. You're going to have to copy it locally and then move it up. And that's a pain. And the users forget. And so they just put it on USB and walk out of the lab. This can grow out of control pretty easily, especially if you have wet lab researchers deciding on what their data hierarchy structure should be. It can be really difficult to find data afterwards. Again, you still need to get the data somewhere where it can be processed. And for us, that's usually S3. So if you've got the data in Ignite, how are you going to transfer it to S3? Jess for Protein Simple and the SpectrumX common use cases that we see for this. Solution that we've toyed with even back when I was at Takeda is to use a storage gateway to expose S3 storage as a mountable file system. This looks appealing because now you can acquire data directly to where it needs to be acquired without an intermediate step. You don't have to copy it around, you move it. It can be a little tricky, and this is where it starts to break down with performance, because Amazon will tell you over and over again, this is not a file system, this is object storage. It's like, yeah, we're going to use it as a file. This is where you start to see performance issues, and it starts to break down. A lot of lab computers run on ancient versions of Windows, and they're going to require you to use the SMB protocol as opposed to NFS. This just provides, again, more performance issues. This does require some overhead and maintenance. You really need a cloud engineering team who's going to be able to provision this for you. If you don't have that internally, you're going to have to find partners who can do it for you. Again, latency-sensitive instruments may or may not be able to support this. And there's a couple of different ways to create a storage gateway. One of them is really easy because you could spin up an EC2 in AWS and run the gateway there, and you don't need to put hardware on site. That's fantastic, but it's slow. So you can run a storage gateway as a virtual machine on-premise. Now you have the same problem you have where you're trying to rack hardware maybe in a co-located space. So our startups really will choose the virtualized option until they run into some performance issues, and then we need to figure it out. The Phoenix and the Orbitrap use cases that we're seeing for this in our labs today. For really larger data sets that we see, especially in the genomic space, data sync is probably a solution that we rely on a lot. And we use that to write data to a local on-premise file system. And then we use a series of data sync jobs to sync the data up into S3. This is great, but now you've got the data locally, and you've also got the data in S3. Which one is the real one? How do you maintain the health of your on-premise file system? We've done 5 or 6 of these deployments in the past couple of years, and the data governance step always seems to get skipped at the end. So all these companies are now storing 2 copies of this data. You also need a fast internet connection. Direct connect is the best way to do it. If you have a 10 gigabit pipe into your building, you're probably okay. Anything less than that, users are going to complain. Illumina and Oxford Nanopore, usually good use cases for this. And I realize I haven't been explaining sort of the user experience is great. The cost is not so great because now you have to maintain both a team to maintain it and buy the hardware. The data are fairly favorable, and this does provide good security. Another option we see our users gravitating towards our vendor clouds. And so some of the instrument vendors will sell you a cloud subscription with their instrument. It's a line amount in the invoice. No one from IT ever sees it. This is super easy. It doesn't require a ton of setup. The users probably won't even contact IT until they run into a problem. So this is great. Now your data are in the vendor system and not in your system. And how do you get it out? It can also be expensive. Especially these vendors will charge by the volume of data that you're storing, and they will start to rack up bills without even really realizing what happens. Illumina is base space, Thermos Cloud are vendor-provided solutions that have a great spot, have a great user experience, but in terms of cost, security, and overhead, not as appealing. So I'd say Big Pharma has really gravitated towards the scientific data management system. These are not new problems that we're facing, but we're facing them at a much smaller scale. When you have the budget of one of the large pharmas, you can go out and buy a vendor solution. And they'll sell you the promise of this unified acquisition and retrieval, integration with ELNs, an API interface for your wet lab, your dry lab scientists to be able to get at the data, controlled vocabularies and ontologies. In the startup space, they just can't afford to dedicate any resources to this. It requires not only the software licenses, but care and feeding. You have to have at least one FTE and probably some support from a partner like Zipho to be able to manage this stuff. We've talked about this a couple times. The instrument integrations are a moving target. There's new software updates that are going to break parsers, and the SDMSs might not catch up. Now again, you've got sort of the same problem that your data are locked in a vendor system and they're not in your S3 cloud where you need your dry lab scientists to be performing their analysis. So this is great. The user experience, depending on the software system, can be good. Like I said, they're very costly, but they do provide a fairly good, fair access to the data. I'm going to copyright that. We've seen a number of our companies go towards homegrown solutions where they've looked at all these options and just say, I'm a really smart bioinformatician. I'm going to write this myself. It can't be that hard. So they'll code their own file watchers and associate the metadata on ingestion, and then they expose the data via a simple web interface. And that works pretty well. They'll give an API call for downstream analysis. But again, this has come up a number of times today. Now you're in the classic buy versus build dilemma, right? You've built this great system, and now you have to live with it. And especially at a startup, those decisions that you make very, very early on can have huge consequences later when you go to file. So I've gone back and forth on this in my career. I was a software engineer for a time, and I love to build stuff, but I've also had to maintain my own code. So I tend to gravitate towards buying software today. So overall, this is the decision tree, and it's a bit of an eye chart, but essentially if you can acquire the data directly to S3, that's the way you want to do it. If you can't get it to S3, you put it in a cloud file server and then you move it over. If you can get it into storage gateway, you can do that and sort of work your way down the line through data sync to the vendor cloud, and then eventually the use case, for USB. This will always, as long as instrument vendors don't give us a better option, going to be a part of life in the wet lab, whether we like it or not. So spent a lot of time implementing versions of these solutions for our startups over the past couple of years, and we achieved our goal of getting data into S3, into the computational space. And our wet lab researchers came back almost immediately and said, well, that's great. How do I get the data out? And I didn't realize this until quite recently. We told our users, well, you go to the AWS console and you download the files from S3. And they said, yes, you can only download one file at a time. And I thought, that can't be right. And I went to Google, and yes, it's correct. You can only download one file at a time through the S3 console. So the native tools are hard to work with. We tried to give them the CLI. That's not going to fly for a wet lab researcher. Without a planned way for data ingestion, we're relying on users to associate the metadata when they create the file names, and that can be challenging to get compliance with. And then they think, well, how do we link the raw data from the ELN? We find that a lot of our users just attach the instrument files to their Benchling notebook entry, which is great, but now the wet lab researchers have hidden the data from the dry lab. And so if we want to enable sort of the MI, ML workflows that we're working on, the data are locked up in a vendor system, and it's hard for us to get it out. So sort of the standard that we're driving to is we create an S3 URL, and the users, we're encouraging them to link to that with the hope that it doesn't break. This is not an endorsement. This is just sort of a tool that we're starting to see adoption of called Quilt. It is a sort of a layer on top of S3 that solves a lot of problems both for the wet lab and the dry lab. It provides sort of a clean user UX for the users. They log into a website and they can see their files. They can tag those files with metadata, and they can create sort of data packages. They say, this is for this experiment or this study in this project, and they can wrap up both the raw data, the process data, and maybe some analysis in a nice little package. And they can version it, so it's great for traceability. It doesn't solve the problem of us getting the data into S3. We still need to find a way to get it up there. And it requires cloud expertise and support. We're going to have to hire someone on my team to administer this system. So when you go through all the different options, there is no one right answer that's right for every use case. And so this talk is intended to give you some idea of what the pros and cons are for each. The SneakerNet, like I said, it's not going away. Storage Gateway has become my default recommendation for a lot of these things, but it does not work for everybody. If I had a message to give to instrument vendors, I wish some of them more were here, would be to let us have more options when we do this. I think having a native S3 storage option would be fantastic for a lot of our instruments. And it should not be that hard to develop. I would say that the incentives for instrument vendors to do this are very low unless those of us in this room sort of push them on it, so we need to do that. Again, instrument vendors don't allow saving data. Some of them don't allow saving data to network drives. We need to push them to fix their software to allow data to be streamed over the network. So let us install antivirus and backup software on machines in 2023. We've had to create, and there was a question for Neil, about how to segregate lab machines in the network. We have a lab VLANs in all of our labs, but we have like a separate special lab VLAN for those machines that we can't patch and manage. And that's just extra overhead for our network team, and they always mess it up, and we always have to work through it. And I tell the scientists that if the data sit on your local drive, it's useless. And the message is starting to get through. So I'll be happy to take questions. I do want to acknowledge those that helped me develop this talk. My manager, Brent Sanders, Justin and Kenny on my team. James Dion is at Tessera, and Neil Whitworth really helped me craft these slides. So thanks very much.
Thank you, Chris.
I was hoping I bored you and there would be no questions.
Hey, Chris. Thanks for a nice talk. Drew Lynch, Sanofi. I was curious if Flagship has ever considered adopting sort of data management standards, or Flagship itself adopting a data management system that it could then partition for the companies that it's supporting.
Yeah, we spent a lot of time thinking about that over the past year. And really the problem comes down to, in the startup ecosystem, how do we fund it? And so we've given these companies usually enough money to last for a year. And for us to tell them you have to spend some of that money and pay for a license for a vendor product, it's just a hard sell. So we're continuing to evaluate and push this, and I don't think we've closed the story on that, but right now, yeah, it's a funding issue.
Yeah, quick comment. So it's funny because I agreed with everything you've just said. In my career, I've stepped away from laboratory informatics systems, come back 20 years later, same problems that we had 20 years ago, we still have
it's
today,
frustrating, yeah.
which is really, really surprising. So I think your conclusion is right. We have to apply a lot more pressure on the instrument vendors who are supplying us with the software, because these problems should have been rectified a long time ago.
Yeah, thanks. I appreciate that. Yeah, it's frustrating. Yeah, I feel like I could have been having some of these conversations when I started my career 15 years ago. Yeah.
We can start a consortium, a revolt.
Yes. Come on, I set him up with this question.
How do you make it so easy, Chris? Anyway, so from my experience, I think one of the talks that you talked about is not putting data locally initially. But from my experience, I feel like if there's a network outage or disruption, that file that could have been on the local drive initially, before you dragged it onto the cloud, could have been saved in that case. So in your experience, do you feel like that's not worth the risk?
Yeah, that's the 1 in a million, hopefully, chance is that there's a network interruption at the exact moment that you're writing. Some shops deal with this better than others. I think that's another place where the vendors could step up and cache data locally, for a minute while it's being written out. Those are solved problems. I mean, the video industry manages to do this. Okay.
Any other questions?
Hi, Chris. So you spoke a lot about data coming down the machines. Do you ever experience data that you want to bring into the organization, and that movement of data, and to commingle it with as part of the research? And do you have similar problems like you experienced when doing that?
Yeah, and I tried to allude to this, with getting. Are you talking about CRO data coming in? Yeah. I mean, generally, what we do now is we give them an S3 bucket and we say, dump your data here, and if you need help, we'll tell you how to do it.
As a follow-up, what about security for that? Because I've heard some challenges of if you don't know where the data is coming from, how do you manage to ensure that people haven't seen that data before, or how you secure its access in case there's some access that you don't accidentally provide when you're bringing that data in?
Yeah, I won't pretend to be an expert here. Our cloud engineering team thinks a lot about how they provision users and limit access for that.
Okay. Thank you, Chris.
Thanks.